everyone. Once again, you're welcome to today's learning session. It's my pleasure to have you tune into the channel today. And today we'll be looking at the measures of partitions. The last time we met, we looked at several measures of dispersion, ranging from the range to the mean deviation, to the standard deviation, to the variance, moment, skewness, kurtosis. So today we'll be looking at the measures of partitions, both group and ungrouped data for quartiles, deciles, and percentiles. And as our practice is, we'll take a bedrock for success for today from the Word of God. And that can be found in the book of 2 Timothy 2, verse 15, which says, "Study to show thyself approved unto God, a workman that needeth not to be ashamed, rightly dividing the word of truth." This was Paul's counsel to Timothy, that before he can show himself an approved minister of the gospel, there is a need for him to study diligently the word of God, so that he does not mislead people by giving them false teachings or teaching them false doctrines. In the same vein, God expects us to be diligent in our studies. Whatever study you choose to embark upon, God expects us to study diligently. There is a difference between reading and studying. To read is to scan through something, but to study is to painstakingly go through that document. And so studying requires discipline, it requires focus, it requires avoiding all forms of distraction. And it is only when we study that we can actually show ourselves approved unto God and unto men. When we do not study diligently, we are likely to have a half-baked knowledge. And a half-baked knowledge is as good as no knowledge at all, because you would lead people astray and you can be embarrassed by half-baked knowledge. And so God is calling us to diligently study His word. God is calling us to diligently study our books so that we will be a workman that will not be put to shame, rightly dividing the truth in the word of God and rightly dividing and sharing the knowledge we have gained with others. My prayer today is that as we avail ourselves of this counsel to study to show ourselves approved unto God first and foremost, and then leading us to be a blessing unto men, that God will bless every one of us. Let's pray. Our Father and our God, we are so grateful to you for another learning time. You have counseled us from the book of 2 Timothy 2 verse 15 that there is a need for us to study to show ourselves approved unto you, a workman that needs not to be ashamed, rightly dividing the word of truth. Lord, even in your word, there is a need for us to diligently study so that we are not misled. In the same vein, even in our studies, there is a need for us to painstakingly study our books so that we do not have the wrong knowledge. So Lord, I plead with you for everyone under the sound of my voice that has tuned in to study this day, that as we go through this topic, you would help them even afterwards, like the Bereans, that they will go back to study these things and make it a part of their life, so that when it is expected of them to put down, they will put it down correctly. Bless everyone that has tuned in today. We ask in Jesus' name. Amen. Once again, we'll be looking at the measures of partition. And for the measures of partition today, we'll be looking at quartiles, deciles, and percentiles. So aside from the measures of central tendency that shows us the middle position, measures of partition shows us the various parts into which a data set can be divided. The quartiles divide a data set into 4 equal parts. The first quartile is called the lower quartile. The second quartile is called the middle quartile, or the median of the distribution. The third quartile is called the upper quartile, and the fourth quartile is called the entire distribution. And so we'll be focusing today on how to find the quartiles of both an ungrouped and a grouped data. Remember, in our study on measures frequency distribution, we were able to differentiate between a grouped and an ungrouped data. And as a way of recapping what we said the other time, An ungrouped data is a data set that does not have a class interval, while a grouped data is a data set that has a class size and a class interval. So we'll be looking at how to find the quartiles, the deciles, the percentiles of both grouped and ungrouped data. Just as the quartiles divides a data set into 4 equal parts, the median divides a data set into 2 equal parts. The deciles divides a data set into 10 equal parts. And the percentiles, like the name connotes from percentage, it divides a data set into 100 equal parts. Now let's get started. To find the quartiles of an ungrouped data, we need to make use of this formula, which is the Qn over 4 plus half. This X just shows us the position of the class. Now let's take a look at this. There's an example here. Find the first and third quartile for the following numbers: 15, 3, 5, 13, 8, 10, and 17. In order to find the first and the third quartile as well as the interquartile range, there is a first step that must be followed. And the first step to be followed or to be taken is to rearrange this data set in ascending magnitude. Now, if we look at this data set, 15, 3, 5, 13, 8, 10, 17, it has no particular order. And you cannot solve this question this way. So the first thing to do is to rearrange this set in ascending order. And that brings us to this: 3, 5, 8, 10, 13, 15, and 17. So in order to find the first quartile, we need to use this formula Qn over 4 plus half in order to determine the position of the first quartile class. So since it is the first quartile, it means it is like n over 4 because it has the quartile class is the first class, which is number 1. So 1 times 7, which is the first quartile class, because we have 7 numbers: 1, 2, 3, 4, 5, 6, 7. So we can see that we have 7 numbers. 1 times 7 divided by 4. It is divided by 4 because a quartile divides a set into 4 equal parts. So 1 times 7 is 7 over 4 plus half. So that gives us 2.25 position. So we see that the 2.25th position, we need to look for where it lies. Now let's take a look at that. 1 times 7 gives us 7. 7 divided by 4 gives us 1.75. 1.75 plus 0.5 gives us 2.25. And that's how we got the 2.25th position. Now we need to go back to the data set. 3, 5, 8, 10, 13, 15, and 17. We need to look for where the 2.25th position lies. Now, because of this fractional value, it may be difficult to actually say where the 0.25 position lies. So what do? First, let's pick the whole number, the second position, the 2 position. So where is the second? What number is on the second position? The second position, of course, is 5. And that is how we got this 5. Now we need the 0.25 between the second and the next number. So, of course, the 0.25 will lie between 5 and 8. We can't get the exact value, so we need to look for the 0.25 of the difference between 8 and 5, which is the next number. And that is how we got 5 plus the remaining 0.25. Please remember, 2.25 is not the first quartile. It is only showing you where the position is. So it means that the first quartile lies on the second 0.25th position. The second position is 5, and we'll find the 0.25 of the difference between the third and the second position. And that is how we got 8 minus 5, which is 3. 0.25 times 3 will give us 0.75. And 5 plus 0.75 gives us 5.75. So our first quartile lies between 5 and 8, and the exact value is 5.75. Now let's go to the third quartile. The third quartile class will be 3n over 4. Just like in the first quartile class, we have n over 4. So this Q is showing you the particular quartile class you're looking for. So since it's a third quartile, it becomes 3n over 4. There are 7 numbers in all. 3 multiplied by 7 divided by 4 plus half gives us 3.75 position. So we need to look at where the third position is and find 0.75 or between the fourth and the third position. Now for the third position, for the third position, we have, so to find the third quartile, we are going to be using 3n over 4 plus half in order to get the positioning. It is 3 because it is the third quartile. So 3 multiplied by 7 divided by 4 plus half will give us 5.5 position. So we need to look for where the fifth position is and look for the 0.5 of the difference between the sixth and the seventh. So we are going to be looking for the third quartile. In order to look for the third quartile, that will be the third position. So we are going to use the formula 3n over 4 plus half. 3 times 7, since we have 7 numbers in all, divided by 4 plus half. So 3 times 7 divided by 4 gives us 5.25 plus half. That gives us 5.75. So the third quartile lies on the 5.75 position. Now how do we get that? We look at the data set. This is the first position, the second, the third, the fourth, and the fifth. So the fifth position is 13. And then we'll look for the 0.75 of between 13 and 15. So the same way we saw for the initial one. So that will be 13 plus 0.75, which is the remaining of the 5.75 position, into bracket 15 minus 13. And so that gives us 14.5. The interquartile range is the Q3, that's the upper quartile minus the lower quartile. So the upper quartile is 14.5 and the lower quartile is 5.75. So 14.5 minus 5.75 gives us the sum of 8.75. We move on to the quartiles of a group data. For a group data, the ball game appears differently. There is a formula we would need to use mathematically. We looked at how to derive the quartiles, the deciles, the percentiles using graphical method under the ogive when we studied about the ogive. However, now our focus is to use the mathematical method to derive our quartiles. That takes us to this formula. The formula for the quartile is your Q1, this is your first quartile, is equals to your L, which represents, or your L1, which represents your lower class boundary of the first quartile class. Your N over 4 represents the quartile class. Your CF into K minus 1 represents the cumulative frequency before your quartile class. The F of K represents the frequency of the quartile class in question, and the C represents the class size. Now let's look at this. So we can see the L1 representing the lower class boundary of the first quartile class. CF into K minus 1 is the cumulative frequency of the class before the first quartile class. And that's because we are dealing with the first quartile. So if we are dealing with another quartile, it's going to be of that particular quartile class. The frequency F of K represents the frequency of the quartile class. And your C represents your class size. Don't forget, your N represents your number of data. Remember that this formula is related to the same formula we use for the group data for your median. The only difference is that instead of N over 4 in quartile, as in the case of quartile, we have N over 2 in median, because median divides a set into 2 equal parts. So the only difference between this, this quartile formula and the median formula is just the quartile class, which is the n over 4. For the median, it will be n over 2. For the deciles, it will be n over 10. For the percentiles, it will be n over 100. So once you know your median formula, you can actually apply it to every other measure of partition. Now let's take a look at this example. So let's take a look at this example. From this example, we are asked to find the lower and the upper quartile of the weekly earnings shown in the table below. Now, this is an example of a grouped data. So what we did initially was the quartiles of an ungrouped data. So now we have to find the lower and the upper quartile of this group data. 75 to 79 with a frequency of 1, 80 to 84, 85 to 89, 90 to 94, and 110 to 114 with a total frequency of 312. And when we studied about the ogive or the cumulative frequency curve, in that topic, we looked at how to calculate for your cumulative frequency. But as a way of revising that, we have to calculate this cumulative frequency because you may not be given this in your question. It is just for you to add your frequencies in successive manner. This is 1. So the first cumulative frequency takes 1. So 1 plus 26 gives us 27, 27 plus 46 gives us 73, 73 plus 62, 135, 135 plus 84, 219, 219 plus 50, 269, 269 plus 37, 306, and 306 plus 6, 312. So the last cumulative frequency must equal the sum of your total frequency. Now let's look at how to calculate for the first quartile. Remember that the formula for the quartile still remains Q1 is equals to L plus N over 4 minus CF into K minus 1 over F of K into bracket C. Do not forget this formula. L1 plus equals, open a bracket, N over 4 minus CF into K minus 1 all over F of K into bracket C. Your N over 4 is your quartile class. This is the lower class boundary of your quartile class. So let's look at it. 312 divided by 4, which is our N over 4. So the 312 divided by 4 gives us the 78th position. So it means that our first quartile class lies on the 78th position. Now, how do we get the 78th position? We need to go back to the table. Let's take a look at the table so that you can see where the 78th position lies. Now, it is assumed that the highest value here is 1. This is assumed to range from 1.1 to 27.0. This is assumed to range from 27.0 to 73. This is 73.1 to 135. This is 135.1 to 219. So the maximum value here is 219. This ranges from 219.1 to 269. This is from 269.1 to 306. And this ranges from 306.1 to 312. So the question is where the 78th position lies. Of course, if the maximum number here is 73, and this starts from 73.1 to 135, so our first quartile class, which lies on the 78th position, lies here, and that is on the fourth class, which is between 90 to 94. 90 to 94. So the lower class boundary of this class of the 90 to 94 is 89.5, which is 0.5 minus the lower class limit. So this is 89.5. The frequency of that class is 62. And of course, the class size 90 to 94 has a size of 5. 90, 91, 92, 93, 94, a class size of 5. So we put it into the formula, and that is how this was arrived at. Let's look at it. So the 78th position lies on the fourth class between 90 to 94. The lower class boundary of that class is 89.5 as explained from the table. The n over 4 is 78. The cumulative frequency before that class, let's look at it on the table again. The cumulative frequency before that class. Let's look at the table. The cumulative frequency before the first quartile class is 73. So that is how this was arrived at. So we can see the 78, which is the first quartile class, n over 4. 312 divided by 4, 78. CF into K minus 1 is the cumulative frequency before the first quartile class, and that is 73. The frequency of the first quartile class is 62, and the class size is 5. So solving this mathematically, we have 78 minus 73, which is 5 over 62. 5 over 62 multiplied by 5, then we add it to 89.5, and that is how we got 89.9. Please take note. When solving this question, you solve everything in the bracket before you add it to the baseline that is given. In the same vein, we are asked to calculate for the third quartile. The only thing that changes in this formula is instead of using n over 4, it becomes 3n over 4 because we are looking for the third quartile class. So the 3n over 4 is 3 times 312 divided by 4, which gives us the 234th position. So we need to look for where the 234th position lies. Please, let's take a look at that. Where does the 234th position lie? So the 234th position lies on the 6th class as established on the table. Let's take a look at the table again so that we can see how we arrived at the 234th position. As explained earlier, we'll see that 219 ends here, and this begins 219.1 to 269. So 234 can be found within this range, and that range falls on the 1, 2, 3, 4, 5, 6 on the 6th class, and that is between 100 to 104. The frequency of that class is 50. The cumulative frequency before that class is 219. The lower class boundary of that class will be 99.5. So let's put it into the formula and let's see what we arrive at. Putting that into the formula, we have the 99.5, which is the lower class boundary of the 100 to 104 class, which is the 6th class, plus 234, which is the Q3 class, minus the cumulative frequency before that class, which was 219. The frequency of that class is 50 multiplied by 5, which is the class size. 100 to 104 have 5 numbers in between them. When we solve this mathematically, 234 minus 219 divided by 50 multiplied by 5, and we add it to 99.5, we get the sum of 101. So the Q3 is 101. In case we are asked to calculate the interquartile class, it will simply be Q3 minus Q1, which is 101 minus, which will be 101 minus 89.9. And if we are asked to calculate the semi-interquartile class, it will be 101 minus 89.9 divided by 2. Take note, the middle class is the same thing as your median, while the fourth class or the fourth quartile is your entire distribution. Your Q1 is your lower quartile and your Q3 is your upper quartile. We move on to deciles. Deciles divides a data set into 10 equal parts. So there are 9 deciles that could be formed using various formulas. We are going to first solve for the quartiles of an ungrouped data. And just as we saw for the quartiles of an ungrouped data, the deciles for an ungrouped data is simply given as dn over 10. So instead of using n over 4 or Qn over 4, we'll use Dn, where the D represents the decile class we are looking for, over n, which represents the total number given in a data set, divided by 10, because deciles divide a set into 10 equal parts, plus the half. This is the formula for the ungrouped data. Now let's solve this question. Find the 5th and 8th decile for the following numbers: 15, 3, 5, 13, 8, 10, 17. And please take note, you can actually find the decile for any number, and we are asked to find the interdecile range. So to find the 5th and 8th decile, the first step is to rearrange the numbers in ascending magnitude. After arranging it in ascending magnitude, so we have this. So the 5th decile now becomes 5 times 7, which is the total numbers we have here, divided by 10 plus half. So 5 times 7, 35, divided by 10, 3.5 plus half. So the 5th decile lies on the 4th position. Now in this case, you do not have a fractional value. And so because you do not have a fractional value, you are not going to find the fractional difference between the next number and the next number. You just simply go to where the 4th number lies after you must have arranged them in ascending order. So let's count together. This is the 1st, the 2nd, the 3rd, and the 4th. And that is how the 5th decile came to 10 as a 5th decile. Now to calculate the 8th decile, you apply the same thing. 8 times 7, 8n over 10 plus half. 8 times 7 divided by 10. 8 times 7, 56, divided by 10, 5.6 plus half, we got 6.1 position. So let's look for the 6th position and find 0.1 of the difference between the 7th and the 6th position. So the 6th position is 1, 2, 3, 4, 5, 6. The 6th position is 15. And that's how we came to 15. The remainder of this positioning is 0.1. So we find 0.1 of the difference between the next number and the previous one. So 15 plus 0.1 of 17 minus 15. And that is how we came to 15.2. For the interdecile range, it is simply D9 minus D1. So we look for the 9th decile using the same formula, look for the 1st decile using the same formula, that will be n over 10, and we solve and find the difference between the two. So we move on to the deciles for a grouped data. When solving for the deciles of a group data, the same way we solve for the quartiles of a group data is very similar to the way we'll solve for the deciles of a group data. Now this can be written as dn over 10 or kn over 10. The symbol is immaterial, provided you are able to explain what the symbol represents. Your L1, now we are looking for a decile class, let's say D4. So your L1 will be the lower class boundary of the desired decile class. In this case, it will be the 4th decile class of the desired decile class. Your N is the number of data. So your Kn over 10 is your desired decile class. Your Cf into K minus 1 is the cumulative frequency of the class before the desired decile class. Your F of K is the frequency of the decile class. And your C is your class size. So let's take a look at the same example, but now we'll be looking for the 4th and the 7th decile of these weekly earnings. The same example we saw for quartiles, let's take a look at it, and let's solve for the 4th and the 7th decile. So solving for the 4th decile, the first thing we need to look out for is to find the 4th decile class and where it falls to. Now let's take a look at this. The 4th decile class, which is 4n over 10, before we apply it into the formula. 4 times 312 over 10 gives us 124.8. 124.8. Now let's look at where 124.8 lies on the table. 124.8 lies here on the fourth class because this is 73. If this is 73.1 to 135, so 124.8 would lie here. And that is the fourth class. And based on this, it then means the lower class boundary is 89.5. Now let's look at this. So we can see that the fourth class is between 90 to 99. 89.5 plus 124.8, which is the 4n over 10, minus the cumulative frequency before the fourth decile is 73. Let's confirm that. Let's confirm the cumulative frequency before that class so we can see it. 73. The cumulative frequency before the fourth decile class is 73. And the frequency of the fourth decile class is 62. So putting it into the formula, we have this. So 124.8 minus 73 divided by 62, multiplied by 5, which is a class size. And then we subtract it from, we add it to 89.5, and that gives us 93.7. 93.7. So to solve for the seventh decile class, it is still going to be 7n over 10. 7 times 312 divided by 10. Let's see what we arrive at with that. 7 times 312 divided by 10 gives us 218.4. So we need to look for where 218.4 lies on our table. And check the cumulative frequency before that class as well. So 218.4 lies on the fifth class range. That is 95 to 99. Because 218.4, we can see it here. This is from 135.1 to 219. So 218.4 lies here. So the lower class boundary of that class will be 94.5. The frequency of that class is 84. And the cumulative frequency before that class is 135. And of course, the class size remains 9, 95 to 99. So let's take a look at it. So 95 to 99 is the class range. 94.5 is a lower class boundary. 128.4 218.4 is what should be here, not 128.4, because the seventh decile class is 218.4. This must have been a typo. So 218.4 minus 135 divided by 84 into 5. 84 is the frequency of the fifth range. That's the seventh decile class. This is the cumulative frequency before that class. 218.4 is the seventh decile class. So when we subtract 218.4 minus 135 divided by 84 multiplied by 5, we will get the sum of 4.96. We can try that out ourselves and you would see that it is a sum of 4.96. So that shows you that this value should be 218.4. It was a reversal of figures. So 4.96 plus 94.5 gives us the sum of 99.46, which is the seventh decile. We move on into the percentiles for an ungrouped data. And as earlier stated, percentiles divides a data set into 100 equal parts. 100 equal parts. So to find the percentiles of an ungrouped data, it is the percentile class in question divided by 100 plus half. The example we are to solve, find the 20th and 80th percentile for the following numbers: 15, 3, 5, 13, 8, 10, and 17. We are to find the 20th and 80th percentile. Let's stop at that. So the first thing to do when finding the 20th and the 80th percentile, as in other case, is to rearrange the data set in ascending order, in ascending magnitude. Now let's take a look at this. When the data set is arranged, it becomes 3, 5, 8, 10, 13, 15, and 17. So the 20th percentile class is 20n. That's 20 times 7, because your n has 7 numbers, divided by 100 plus half. 20 times 7 divided by 100 plus half gives us the 1.9th position. The 1.9th position. Now, where is the first position? The first position is 3. The number that lies on the first position is 3. And that is how we came to this 3 here. We are left with 0.9 of the difference between the second and the first position. So that is 0.9 of the difference between 5 and 3. 5 minus 3 gives us 2, multiplied by 0.9 and added to 3 gives us the total sum of 4.8. So our 20th percentile is 4.8. We go on to calculate the 80th percentile, which is 80n over 100 plus half. 80 times 7 divided by 100 plus half. Please, this should be 100 plus half. Gives us the 6.1 position. The 6th position, 1, 2, 3, 4, 5, 6. The 6th position is 15. Then 0.1 of the difference between the 7th and the 6th position is 17 minus 15, which is 2 into bracket 0.1 plus 15. And that gives us the sum of 15.2. So the 20th percentile is 4.8. The 80th percentile is 15.2. We are asked to also solve for a group data. In order to solve for the group data, the same formula that was used for median, deciles, quartiles will also be used. The only difference is that instead of dividing it into 2, 4, or 10 respectively, it divides it, your percentile class divides it into 100 equal parts. So that's how we came to the formula. P, which is the percentile class in question, equals to L1 plus Kn over 100 minus Cf into K minus 1 over F of K into bracket C, where L1 is the lower class boundary of the desired percentile class. Your K is the desired percentile class. Your N is the number of data observed. That's your sum of frequency. Your Cf into K minus 1 is the cumulative frequency of the class before the desired percentile class. Your F of K is the frequency of the desired percentile class, and your C is your class size. Now let's take a look at this. We are asked to find the 70th percentile of the weekly earnings for the same table. So in order to solve for the 70th percentile, we would have it as 70n over 100. That is the percentile class. And when we solve that 70n over 100, we have 218.4. Now, if we check where 218.4 lies on the table, 218.4 lies on this range, and that is 95 to 99 on the 5th class range. So the lower class boundary of this is 94.5. The frequency of that class is 84. And the cumulative frequency before that class is 135. Let's put it into the formula and let's solve that. So we have 94.5 into, this should be 218.4 minus 135, which is the cumulative frequency before that class, over 84, which is the frequency of the median class, of the 70th percentile class rather, into 5, which is a class size. And that brings us to 94.5 plus 4.96. I repeat, this is a lower class boundary of the 70th percentile class, 94.5. This should be 218.4 as gotten here, minus the cumulative frequency before this class, that is 135, divided by the frequency of the 70th percentile class, which is 84, multiplied by the class size. And that gives us 4.96 plus 94.5. And that brings us to 99.46. So you can actually be asked to calculate any of the decile class, any of the quartile class, any of the percentile class, both for grouped and ungrouped data. And these things are very easy and straightforward. I want you to try this. The scores of students in the last statistics examination are recorded below. Find the mean, median, mode, as well as practice all forms of quartiles, practice all forms of deciles possible, practice all forms of percentiles on this data set and see what you come to. And please, don't restrict yourself to just this question. Try and lay your hands on as many questions as possible. Today, we have looked at what percentiles are, what quartiles are. We have looked at measures of partitions, and we have been able to establish the quartiles for both grouped and ungrouped data. We have looked at the deciles that divides a set into 10 equal parts for both grouped and ungrouped data. We have also looked at the percentiles for both grouped and ungrouped data. Please keep practicing until this thing becomes very natural with you. Thank you so much for listening. Do well to subscribe to the channel, write your comment, and God bless you. Let's pray. Our Father in heaven, we are grateful to you for the class of today. We plead with you for everyone under the sound of my voice, that Lord, you bless them with knowledge and help them to be able to practice it when it is expected of them and to put it down correctly. Thank you for answered prayers. In Jesus' name we have prayed. Amen. God bless you till we meet again.